Hello, welcome to this lecture. In this lecture, we'll be going over the web application landscape. We'll be looking at different types of web application developer roles and the types of web applications you could write. Also, a little bit of history to kind of know where we've come in web development to where we are now with web applications, and also how to keep up in the industry because it moves so fast. So with that, let's move on and move forward to looking at your computer science foundation. And in your quarters and years taking your computer science courses, you've got a lot of awesome theory under your belt. You have some technical chops. So whether it be weekly assignments, capstone projects, final projects, you put in many hours of learning technical skills, programming, applying those, which allowed you to apply problem solving, critical thinking, which is an awesome foundation. That's a foundation that you received in computer science. And with that, you then can take that foundation and apply it to so many fields. And so, for example, there's mobile development, for your devices. There's embedded small chip programming. There's web applications, and that's this one particular field that we're talking about this quarter in this class. There's developer operations, keeping systems of computers up and running. There's cloud computing. There's Internet of Things, everything device connected to the internet somehow and communicating. Machine learning, data science, low-level operating system code, robotics, game programming. There's a lot. These are just a few of many fields that you can apply your computer science skills to. And so I think that's exciting. I think there's lots of opportunity out there for you, and web applications is just one of them. So with that, I want to dive deeper into web applications and go into, some developer roles, some team roles, and how they kind of all fit together. So roles, you might have a graphic designer who is good at, for example, Photoshop, image optimization, and I think the image optimization is really important here, especially in a web application role, because you might have a print graphic designer whose job is to make things highly detailed, is not concerned about image size. They want something to look good on a poster or in a magazine, and they're not concerned about image size. But for web applications, a graphic designer, they have to be ultimately concerned about image optimization because that's something that's being downloaded from a server over the internet to a client computer. And so it needs to be optimized to be downloaded as fast as possible, yet look good too. So, I think that's really important, and so that's a great and very important role. Web designer. So web designer is usually good at CSS or cascading style sheets, and so their job is to make things look good on a web page in a responsive manner. So if you resize a browser, things should move around on the page in a responsive way and still look really good. Someone should be able to pull up your website on a mobile browser and it should look good. So web designer is critical into getting things to align and look great on a page. Front-end developer, I put JavaScript whiz because oftentimes they're the ones writing JavaScript code, either vanilla JavaScript or using a framework to get things to look good and interactive on a page, and also structure the code so that it's can grow over time and as team comes in and starts using the code as well. So they'll also be the ones interacting with the data that they might get from the back end or the server and optimizing the usage of the data on the front end as well. A back-end developer, they also are they're into highly optimized large code bases, large teams possibly working with the database, making things efficient on the back end, architecting uh, lots of code, so they enjoy that. That's what they like. They like solving hard problems on the server. And so, and then also optimizing database calls as well. So that's a back-end engineer. Full stack, I put jack of all trades, master of ... And it's just kind of a joke, but actually full stack engineer is very, very important because they need to be able to do some front-end work and also some back-end work. You may find a full stack developer more often like it in small teams or agencies because they need to be able to do everything. They have to be able to put the whole thing together. I also think full stack developers are excellent communicators because they oftentimes have to communicate with a larger team and understand the full scope of a feature. So they need to be a good communicator with like a project manager, graphics person, web designer, front end, back end. They need to be able to communicate with everybody and incorporate those ideas into a feature. So these are some pretty common roles that you'll see in the web application world. So team size. What size of teams will a web application developer see? Well, you could be just a lone wolf. You could just be a consultant, and that's kind of what I'm doing right now. I'm my own boss right now. I'm a consultant. I happen to work on a government project right now where the team is probably like 3 or 4 developers, and I work with them and we all work together. But I'm also doing other projects as well. You could be working on a small team, maybe less than 5 people. And another example of that is I've worked on a team where we were all part of the same company. There was probably about 5 of us, and we would solve problems, write projects for companies out of Utah, Washington, and other areas as well. And we were a highly, tight group and solved some pretty cool problems that way as well. There's agencies where you may be 1 or 2 engineers on a team amongst a lot of other marketing, graphics people, but you're again working in a team in that environment where you're putting out products within weeks and months, like pretty quick turnaround. So that's something you would commonly see like in an agency. There's large businesses like over 100, but then there's also enterprises which could be over thousands or 10,000s. So again, you could find yourself in many sorts of team sizes in different sorts of companies that all have different ways of working, but allows you to use that computer science foundation and your web application skills within these environments. So it's pretty cool. Here are some application types. So you have a static blog, static brochure type sites, blog, content management systems or CMS. Oftentimes you'll see those built in like Drupal or WordPress, which, side note, those are actually written in PHP, and they've been around a long time and have huge base of developers that are contributing to those like all the time. And so very highly established in the industry for building out CMSs. Again, you could have e-commerce, storefronts, business apps, internal tools. The reason why I put internal tools on there is, for example, like in enterprises, when I was down in San Francisco Bay Area working at Apple, I worked on internal tools. So they might not be like customer facing like on apple.com, but internal. I worked for the iOS wireless group, and they needed tools to help them do their jobs better. So for example, Apple had a fleet of cars, like 12 cars, that they purchased and they would use specifically for testing Bluetooth in the car. And so I wrote an app that scheduled the check-in, check-out of those cars. People could check them out, test it for a week, and then I also wrote a reporting tool where they would come back, write up their experience using Bluetooth in the car, and then the iOS wireless group would use that data to fix bugs, make things better, and ensure high quality Bluetooth. So that's an example of an internal tool that I wrote. So there's software as a service, or SaaS, and these are basically online websites that basically take ideas that used to be traditional, maybe computer type applications, and convert them into an online type of thing. So for example, like Gmail, Google Gmail, commonly is just an email app on your computer, but they turned it into something you can open a web browser and use email from your web browser. Also, another example is like TurboTax. TurboTax used to be like this piece of software on a CD that you would just stick into your computer, install it, and run off on your computer. Well, now you just log in the browser, log in, and do your taxes from their service. So, that's a lot of that transitioning of software, converting it into a service and just running it online. Other types of app is social cause, so like change.org is an example. Health and medical applications. I worked on a project last year where a medical facility would give these special weights, like a scale, to people. They would take home and they'd have to weigh themselves like once or twice a day. And the device actually, when they weighed themselves, would send the data over the internet to our servers over an API, and we would record this data, and then the doctor could actually watch trends in their weight, and then prescribe things when they meet with them like once a month or whatever, kind of talk to them about what's going on with the data that they're seeing as they step on the scales every day. So that kind of stuff is, especially in the medical field, there's a lot of recording of data so doctors can have quicker answers. They can see trends quickly. So cool stuff. Other, marketing, promotional materials, and then education type apps as well. An example of an education app is the Canvas. We all use Canvas to organize and look at coursework for this site for the college, and that's a huge app. And so they got lots of developers working on that. There's other types of educational applications out there as well. Google Classroom's another one, but there's dozens of those. And so these are, again, just some of many types of applications that can be written out there, and there's more. It's endless. All right, well, let's transition over to some history. This is the first web browser ever used, called Mosaic. And a little bit of history, this was back in '93, and I remember walking into the computer science lab at Eastern Washington University. And that's where I graduated. I graduated in '97 with my bachelor's, and in '98 with my graduate degree. But in '93, I walked in the computer science lab, and I used Mosaic. And that's when the web came out. That's when it became free. And educational institutions were one of the first to get the web and allow students to use the web. And so that was, the '90s were the wild, wild west of the web. And it's just cool to see it go from where it was to where it is today. And it's just been a tremendous trajectory of technology over that time. But as you see, 96 JavaScript was created to provide interactivity to your web pages beyond HTML. And then 1998 was cascading style sheets, just to add that structure and visual design to a page. So furthermore, during the 90s, if you're looking at server-side dynamic pages, so pages that are generated on the server and then sent out to the client, you'll hear things like Perl, CGI, ASP, active server pages, PHP. funny quote from the inventor of PHP, because he was just writing some scripts that was just helping himself, and so he just was writing, some, PHP, kind of created it on the fly just for himself, and it started taking off, started getting super popular. And then he comes out with this quote. He's like, I didn't know how to stop it. There was never any intent to write a programming language. I have absolutely no idea how to write a programming language. I just kept adding the next logical step on the way. And it's just kind of funny because you can see the roots of PHP. It's I guess, early PHP was super messy. It was just kind of like duct tape and wire. And it kind of got a bad rap. It got a bad name in the industry of like, oh, PHP code is kind of messy, and the people who use PHP write messy code, and so it kind of got a bad rap. It's since it's starting to get away from that history, and it is nowadays more, it's modernized and mostly caught up, with the way things are done nowadays. But back then, had a bad stigma. It might still have a bad stigma to some people if they don't know about some of the new things that's happening in the PHP world. But it definitely had it back then. So this is just a visual of what you'll see the web server, which is where the PHP code is interpreted and ran, and then it generates the HTML, which is sent out to the client to view. And we'll get more into this kind of stuff when we start writing our own PHP scripts. In the early 2000s is when enterprises got more involved. So like Sun and Oracle wrote J2EE. This was like their enterprise version of web application development. And it was like huge and clunky and supposedly powerful, but a lot of apps got written in it, and a lot of people are still writing those today. Microsoft came out with ASP.NET and C#. Cold Fusion is still a name. It was a name back then, probably less so now. Zend Technologies was a company that actually started funding the development of PHP. So they saw PHP. They knew it was growing. They knew it was, grassroots was becoming popular. So they wanted to kind of grab it, invest in it, start developing it, and get it improved in an organized fashion. Spring Java framework, still, if you're doing any Java web development, you're probably going to run into Spring. That's really popular, very widely used. I've done a project in Spring back in the day, and so don't be surprised if you see Spring being used for that. If you jump into a company or a consultancy that uses Java for web stuff. So in the later 2000s, so mid to late 2000s, Ruby on Rails became super popular. Django came out and is super popular. CodeIgniter was a framework for PHP that started to make it a little bit more structured. I would say it's still not the best framework. I would not recommend it, but from where PHP was, it made it a little better. Microsoft continued to evolve their web framework, ASP.NET MVC. Node.js came out and became that took off, super popular for writing highly asynchronous, real-time web applications. Express and Sales are two of many commonly known web frameworks. And then jQuery is not so much a web framework, but a JavaScript library that just became super popular. So I can't really talk about web development unless I bring up jQuery from mid to late 2000s, which really helped on the front end a lot, helped build the foundation of getting people to think about writing larger applications on the front end. And so again, when I say later 2000s, right, that's still 10 to 15 years ago. That's still like a long time ago. I mean, it seems like yesterday to me, but 10 to 15 years ago is a long time ago in web technology years. So just crazy how it's progressed. 2010s, we have JSON APIs. And JSON APIs, so JSON is basically a way to structure data that is that's native to JavaScript. And so JavaScript became, more and more popular and used. JSON become more popular and used. And for that reason, if I jump back a couple slides to this picture, notice the page being sent back is in HTML. Well, that's how very, traditional web frameworks, that's how they do it. They send back HTML. Well, in a front-end framework using JSON, they send JSON data structure back to the client. And it's up to the front-end framework to consume that data, put it into HTML, and make it look good and interactive. So then the front-end frameworks like Ember.js, Angular, React, Vue.js, Svelte, these front-end frameworks consume and use the JSON, make it look pretty and interactive, which is cool. Another thing that took advantage of JSON APIs are mobile apps. So iOS apps, Android apps, etc. They also consume JSON and use it in their apps as well. So recent history, so last 5 years, front-end frameworks are still hot. Web frameworks continue to mature. So in the PHP land, Laravel is the web framework we'll be using in this course. And that finally, PHP version 7, Laravel actually make PHP legit language and framework to use for web development. And so, hopefully the stigma that PHP had back in the day can go away. And the things we can do in Laravel is same things we can do in other frameworks like Rails, Django, etc. You can write some very highly organized, structured, well-written code in PHP 7 and Laravel. So that's good news. Ruby on Rails continues to be highly used. Django is highly used. These are established frameworks now. Microsoft is continually evolving their stuff. ASP.NET Core and Node.js is still out there. Again, many libraries built on top of Node to do some pretty, great web stuff. So languages on the rise. Go, that was written by Google. Rust is like an open source language that is written to be highly modern, but also very fast. So you're seeing a lot of C++ type projects rewritten in Rust. And then Elixir is a highly concurrent language, which also handles real-time applications very, very well, highly scalable. So I'm currently working on a project in Go, and I'm writing the back-end API in Go and the front end in Vue. And last year I was part of an Elixir project, and again, highly concurrent, highly interactive, real-time, and so good stuff. So on the rise, and definitely you'll probably be seeing those more and more as well. So with that said, cutting edge, all right? So what are some things coming down that we at least need to be aware of? There's some web frameworks called Next, Blitz, and Redwood. And you're like, what the heck, where are these coming from? Well, this is just how it works in the web technology world. Just it never stops. It just keeps evolving. And so what these frameworks try to do is make it even easier to spin up, an API app, even easier to consume, to dish out JSON, make it easier for front-end frameworks, mobile apps to interact with them. And so their goal is to get you up and going even quicker. And so definitely keep your eye out for those. Another API standard you'll see out there is called GraphQL. And Facebook invented that, and their idea is they're trying to make it even easier to query APIs. And so again, something to keep your eyes on. This talk obviously is just, again, high level. I can't deep dive into these as as much as I'd love to, but we just don't have the time to do that. But at least you should be aware, at least you've heard it. If it comes up in the future, you can look into it a little further, but definitely something to keep up on for sure. So how do you keep up? How do you keep up with the industry? Here's a few things that I personally use to keep up with industry. ThoughtWorks comes out with a quarterly, what's called Technology Radar. And they have these cool visuals and graphics that show technologies that are on the rise, technologies that you should be using today, technologies that you shouldn't be looking at anymore. And this is based off, industry research, and they organize it in a real nice, easy to consume fashion. Definitely check that out. Stack Overflow comes out with an annual developer survey where they survey their developers that use their site, and they give demographics of industry, people, where they live, salaries, type of work, et cetera, et cetera. And that's technologies that people love, technologies that people hate, technologies that people want to start researching. So it's just another little thing to look at that can keep you up to date as far as what the industry is doing. I also encourage you to go to attend local in-person meetups, because that's where people in the industry actually come and talk about what they're working on. So definitely highly recommend that. And then also following thought leaders on like Twitter, LinkedIn. That's what I do. I can see what they're tweeting and posting about, what new things to keep up on there. So I hope that helps. Definitely recommend it. So just in review of this talk, it was a web application landscape. It was a high-level view of the different roles and team types, technologies, some history of the web, and how to keep up in the industry. And I think, taking your computer science foundation and applying it into the web application space is one of many great fields that you can go into. And that's what we're going to spend this quarter doing, is talking about how to apply your skills to web application development. So we'll see you next time. Bye.